Hi, we're Team Early COVID-19 Detector. We're all undergraduate students from Johns Hopkins University, and we decided to pursue track number 3.
So COVID-19 we found is a very challenging disease to diagnose. There's two main methods of diagnosis. One is a nasal swab, which is quick and highly specific. However, it requires lots of advanced personnel equipment and invasive. Similarly, there's also serological testing, where a blood test is done to test for antibodies against COVID. However, again, this is also requiring advanced personnel equipment as well as a long period of incubation to even start producing antibodies.
So our early COVID detecting device has many capabilities. It can measure many symptoms, including coughing, temperature, oxygen saturation, and tidal volume. It also has an LCD panel so that users can interact with the interface. It uses a predictive model to use the data collected to inform users if it is likely or unlikely that they have been infected. And then, of course, version 1 is designed with just parts on hand, so we have several changes that we make in future models.
So some other advantages are that our design is portable since it's pretty small. All the components are not very expensive and they can be easily sourced. And lastly, it's very modular. So as you can see on the picture on the left, there's a hinge so you can open it up into 3 pieces to provide easy repair and battery replacement.
So recently, King's College did a study of over 18,000 people who were using an app that asked for symptoms and also tested for COVID. And so based off their data and a model, we were able to develop our own predictive model for COVID using our sensor data. So here we have the symptomatic formula, which takes in all the sensor data. And here's the actual predictive model formula, which uses that symptomatic formula. And so based off that, if C is greater than or equal to 5, we notify the user that they are likely to have a COVID infection. And if C is less than 0.5, then they're not likely to have a COVID infection.
So future improvements in subsequent versions, we plan to make a custom PCB circuit to greatly decrease the size of our module, use an IR temperature sensor instead of a thermistor for more accurate temperature measurement, and include a Wi-Fi module so that we can transmit data to laptops from which the data can be further transmitted to healthcare professionals.
So some more advanced feature improvements include making the algorithm adaptive, in which we would personalize it to individual data, and it would detect anomalies in each user's trend over time. In this way, we could also use machine learning to improve the prediction algorithm. Lastly, in order to change the interface, we could use voice prompts and a microphone and use speech recognition to collect data rather than using an LCD screen and buttons, since that'd be an easier way to implement the solution.
And so our solution actually enables users to self-diagnose before they actually go and get a swab test. And seeing that our device is also relatively cheap and also reusable and multi-purpose, so whether it's healthcare providers, individuals, or anyone just trying to look at preliminary symptoms to tell if they may have COVID. Thank you so much.
We would like to thank our mentors, Dr. Manisi and Ms. Osnat, for their help on this project. So here you can see our prototype. We have an Arduino Uno and LCD, 2 buttons. The one on the left indicates a yes and the one on the right indicates no. We have a temperature thermistor and we have a pressure sensor which connects to a spirometer here. Now we will do a demonstration. So it says, so now we're going to hold the thermistor up to my head so I can measure my temperature. Alright, so this is 99.6226. Next, have you experienced? Now for the spirometer, we need to do 3 tests. So we'll blow for the first one. See if you can see this. So just exhale into this mouth tube. There's the first reading. And that's the average reading. So now it says your likelihood of COVID-19 is 0.56, which is likely.